Welcome to Tales from the Rabbit Hole. I'm your host, Mick West. My guest today is Professor Avi Loeb. Avi, thank you very much for being here. It's great for you to make the time to do this.
Thanks for hosting me. It's my pleasure.
So you are a professor of science, and I found that very interesting because science, as you know, is very compartmentalized. And even at school, you start out, we start out learning science, and then it very quickly divides into physics, chemistry, and biology. So, and when I looked up professor of science, it doesn't seem to be a very common title. You see things like professor of science communications or professor of science and technology and things like that. How do you get to be a professor of science?
Well, it's a named chair, so it's called the Frank B. Bird, the Junior Professor of Science at Harvard. And I originally was a professor of astronomy because I belong to the astronomy department, but then they gave me a chair position. So that's where the science came in. And of course, the way I view myself is as a broad ranging scientist, in the sense that I worked on many different aspects of science. You know, I worked on the first stars in the universe early on. You might call it the scientific version of the story of Genesis, let there be light. And I worked on black holes for many years, and also served as the founding director of the Black Hole Initiative at Harvard. And I worked on most recently, the search for life in the universe. And so it's a very diverse range of research topics. And, when I started astrophysics, I was given an advice by my mentor at the time, John Bacall. He said, you should focus on a very specific topic so that you can become the world expert. And I never listened to his advice.
Yeah, that's good. I like the idea of being a scientific generalist myself. Obviously, I'm not really a scientist as such, but I like learning lots of different new things, and I appreciate that. And you, before we started this interview, when we were getting it in touch, you advised me to have a look at the series of articles that you write at Scientific America. And they're great. They're really interesting, and I think it gives you a very good idea of who you are and the broad range of things that you are interested in.
In a way, these essays and also my book, Extraterrestrial, are an admission that of my true love, which was philosophy at a young age. When I grew up on a farm, and I was mostly interested in the big questions. Unfortunately, we don't have answers to those big questions, like what's the meaning of life? We are born into this world like actors put on a stage without knowing what the play is about. And most people think the play is about us. And, it started with the ancient Greek philosopher Aristotle that argued that we are at the center of the universe. And people believed him for 1,000 years. It was very flattering to our ego. What we now know is the universe is 10 to the power 26 times bigger. The observable volume of the universe is 10 to the power 26 times bigger than the size of our body. So we're clearly not at the center of the stage. And moreover, the play has been going on for 13.8 billion years. So it's clearly not about us. That's, I understand where this is coming from, because my daughters, when they were young, they thought everything is centered on them. And then they got into the world. They went to the kindergarten and realized there are other kids, and some of them are smarter than they are. And, we still have to mature in that sense. Many of my colleagues still argue that we are alone, and until given extraordinary evidence, they will continue to think that we are the smartest on our cosmic block.
Yeah, I have that kind of experience myself of thinking I was the smartest kid around when I was very, very young. And I was in my little school, but then of course you go out into the broader world and to the universities and you suddenly realize.
Yeah, well, I think it's true for someone like Einstein. He thought that he's the smartest early on, and it was true later on as well. Right. But most people are not Albert Einstein.
And perhaps for you. So you talked about philosophy, and let's talk a little bit about the philosophy of science. And one of the big issues in the philosophy of science is the demarcation issue. How do you decide what is science and what is pseudoscience? And we're going to talk here about UFOs. Right. And obviously, a lot of people would consider the study of UFOs to be pseudoscience. And
I think
disagree.
The distinction is rather simple. Science is, if I had to define it, actually I was asked to define an intelligent civilization. And the way I define an intelligent civilization is a civilization guided by the principles of science, which are cooperation and sharing of evidence-based knowledge. So there are two elements to that. One is cooperation and sharing. And if you look at human history, it's full of instances where humans try to feel superior relative to each other and did not really share. I mean, even recently, the information about COVID-19 was not shared with the rest of the world when it started in Wuhan, China. And that is not a good sign, because intelligence is, trying to promote a better future for all humans. And in that sense, political boundaries and boundaries between countries do not make much sense. You want to help everyone, and nowadays we live in a global world. So that's one of the elements. And then the second one, most important, that makes the distinction between pseudoscience and real science, is evidence-based knowledge. And we see a lot of discussion in politics that is not evidence-based, and in other realms of our life. And I think we will be much better off if we were to be guided by evidence. And by the way, we will talk about the Galileo project, but the entire motivation for me to lead this project is to bring a subject that you might call pseudoscience, because perhaps the evidence that was released to the public was not convincing, and there might be other evidence. It might be like an iceberg where we see only the tip. But I don't really care if there is classified evidence and what the past evidence is. I just want to collect enough evidence to examine it scientifically, because science is guided by evidence and nothing more, nothing less. And we should regard science as a learning experience. For me, science is a privilege of maintaining your childhood curiosity. And, as a child, as a kid, when adults tell you something, you don't believe them. You just go out and check it for yourself. Something bad happens to these kids when they become adults. They stop checking and they start to believe ideas that are not, that are not supported by evidence.
Yeah, and that's something I'm very much against, obviously, because I'm kind of a skeptic / debunker.
That's perfectly fine to be skeptic, and I think it's important to be skeptic, because that if that motivates you to collect better evidence, you are following science.
Yeah, so let's say, just imagine for a second, I got a check for $1 million here, and I want to invest this $1 million in the search for UFOs, because I'm personally convinced to say that UFOs might be alien visitors, and I want to kind of get that out to the world. Why should I give my $1 million to you and Project Galileo?
Okay, so the Galileo project is basically the scope of it is trying to establish the study of unidentified objects whose nature is not known in our atmosphere, to study it scientifically, meaning to collect evidence using instruments that we have full control over. So, for example, past testimonies, do not stand up to the scrutiny of science. You can't write a scientific paper based on what people tell you. You can't say this person said that and submit the paper for publication. That's not acceptable. What you need is to rely on instruments that collect quantitative evidence. And so that's point number one. The second is the instruments that were used in the past on reports on unidentified objects were not optimized for that purpose. They were, for example, a jittery camera in the cockpit of a fighter jet. I mean, that's not a scientific experiment, because you don't know exactly how the fighter jet maneuvered, and you don't know what kind of jitters were introduced to the camera during that flight. And what you want is to have full control and full knowledge of your experimental setup. And that's what the Galileo project wants to do. We don't want to look back at past evidence. In fact, we say that explicitly on our website. Also, the other thing that I should say, we don't want to entertain explanations that deviate from the known laws of physics. So if someone says, oh, actually, there is something really strange going on that violates the standard model of physics, we will not entertain that. We will use our knowledge, just like in a regular scientific experiment. Of course, if we are pushed to the point where the evidence is so unusual that you can say for sure that our understanding of physics is violated, that would be worth a Nobel Prize, of course. And I find it unlikely because there are so many experiments that we've tested the current understanding of the laws of physics that I would really find it surprising if these objects violated. So at first we will use what we know about physics, the laws of nature, and not deviate from that, and then collect as much data as possible using telescopes connected to cameras that feed the data into computer systems that filter it for objects of interest. And I should say, people would ask, okay, what's new about it? We have telescopes operated by astronomers looking at the sky all the time. Well, the answer is if a bird flies above a telescope that astronomers are using, they just ignore it. We will look at it and see that it's a bird and identify it. We will try to get a high resolution image. Just to give you a sense, an object the size of a person at a distance of a mile can be resolved with a megapixel image so that you can see the size of the head of a pin on it using a 1 meter telescope and just standard optics. And in a few weeks ago, I looked online and you can actually purchase such a telescope. You just add it to your bag. There is a button, add to the bag. It costs $500,000. That's a lot of money, but apparently there are people willing to spend that. So the point is, with a big enough telescope, you can tell whether an object the size of a person has a label saying made in China, made in Russia, or made on exoplanet X, and that's what we will. Now, I should tell you that I'm not interested at all in anything that is human made. If it says made in China or made in Russia, that's very boring as far as I'm concerned. I will transfer all the information to Washington, D.C., whoever wants it. I don't, the project is not about that. We don't care about that kind of objects. The two types that are of interest are, of course, atmospheric phenomena, things that happen in nature, were unexpected, and produce interesting events that were previously unappreciated. That's why their nature is not known in the UAP report to Congress. So that's one possibility. And of course, there is a possibility that something out of this earth came nearby. So, we are completely agnostic, without any agenda, just trying to collect the data. And the good thing is, that we are funded by donations. So I did not fundraise. I just got not 1 million, but nearly $2 million over the past few weeks from donors that I've never met before until the last few weeks. And they just decided to support that research. And I said at that point, okay, well, I can assemble exceptional scientists, mostly astronomers, that know how to construct telescopes that will serve the purpose that we need them for. And you might ask, why not use satellite data? There was some satellite data looking down. Well, satellites move around the Earth very quickly. They can't really monitor the motion of a given object in the way that we want it. And so I was asked by many people, why not use existing data? The point is, existing data was never designed for the purpose that we are talking about. This is really a new endeavor, and the reason it was not done in the past is very simple. The science community, scientists, ridiculed this subject and didn't take it seriously. At the same time, there were people out there making statements that do not make much sense, including statements about violating the laws of physics, And then the scientists said, you see, there is no point in us getting engaged because it makes no sense. So the two communities basically created a status quo where not much was done. And then when the report came to Congress, at that point, it looked to me as if it's very intriguing for us to look into it, because former CIA directors Brennan and Woolsey would say this is a serious matter. Former President Barack Obama said this is a serious matter. These are real objects. So if the politicians in Washington, D.C., and military personnel say they don't understand the nature of some objects that appear to be real, at that point in time, I say, let's move this subject away from the talking points of politicians, military personnel, to the realm of science so that we can clear up the fog and resolve it once and for all. This is a subject, we are not in the dark ages, right? So we shouldn't speculate. We can clear it up with the investment of a few tens of millions of dollars, and we can talk about why I need more money in order to do it properly. But the point is, we can clear up this fog and find the answer and then move on. If it ends up being a natural phenomenon, so be it. I have no agenda.
That's a very interesting idea, the idea that you can clear it up in just, I guess, a few years with a few tens of millions of dollars. And that would be great, obviously, if that actually happened. But let's kind of like look at the nitty gritty there.
Yeah.
You're proposing essentially a network of telescopes that are going to get high resolution images of objects in the sky. And you talked about one telescope. It's a $500,000 telescope.
Oh, no.
I looked at it.
So I gave an example of one telescope, a meter size, but we are likely to use slightly smaller telescope because the cost is still an issue. If currently we have
it run out very quickly.
Yeah.
So, the obvious issue with UFOs is that the sky is very, very large. The amount of area that you have to cover is very, very large. And we see UFOs because we have lots of people. And so people looking up in the sky see things, and we have a very, very broad net.
Right.
How are you going to get sufficient coverage to get sufficient frequency of observations?
Yeah, well, that's an excellent question, and we made some preliminary estimates for how many telescope systems we might need, given the area that is covered by each telescope system. Okay, and the answer is given the reports by military personnel, you would need at least 100 stations, 100 telescope systems. As to
over the entire United States?
Well, it could be the US, it could be elsewhere. Of course, the best sites in terms of visibility are mountaintops. That's why astronomers put telescopes on mountaintops, and because the atmosphere is more dilute as you go up, and there is less blurring by atmospheric turbulence, so you can see better to greater distances without deterioration of the image quality. But it may well be. I mean, some people claim that UAP concentrate around the particular locations, like military facilities or nuclear reactors. And the point is, these are the facilities that are most monitored. So it's not clear to me that it's not just a selection bias. But at any event, and obviously, most of the sky is not classified. That's why astronomers use telescopes without any problem. And so we may not approach military facilities because these areas are restricted. But we will try to spread the telescopes over a wide range of environments. And the question of the location is yet to be decided. Where would we put them? But what I'm saying is, currently with the current funding, we can at most fund up to 10 systems.
Right.
And the thing is, we need 100 or more. Yes. So we need 10 times more funding. So we need tens of millions. But if we have that, if we will have that, which I'm optimistic about, because once we demonstrate that we can achieve the data quality that we need, at that point we might get more donors to support the project. And I must emphasize, we are not taking away money from searches. The mainstream science done by the National Science Foundation or NASA, in the sense, people are still searching for the dark matter, for example, right? But that's supported by DOE or supported by NSF. And we haven't found the dark matter for 4 decades. We've been searching, investing hundreds of millions of dollars in the dark, so to speak. And that is mainstream in science. That's mainstream in astronomy, and it's completely legitimate not to find something you're looking for. Like people were searching for weakly interacting massive particles. I don't regard it as a failure that for 40 years nothing was found and just upper limits were set. And I asked an experimentalist, how long will you continue to search? And he said, as long as I'm getting funded. So that is completely, but having 0 or 1,000 times less funding for trying to figure out the nature of these UAP doesn't make much sense to me. So I think at this day and age, science should engage in a topic that is of such interest to the public and clear it up. We are not, 1,000 years ago, there were people saying the human body has a soul and therefore anatomy should be forbidden. Imagine if scientists would say, oh, some people are saying nonsense about the human body. We don't want to engage with the human body. We don't want to have operations because there is all this nonsense said about it. It's a controversial subject, the human body. Think where would modern medicine be? The point is, if science has the ability to address a question that has a lot of nonsense being said about it, it should do it so that the nonsense will stop being said about it, so that we can clear it up and move on.
Yeah, I very much like that. I would like to have more data. I'm a big fan of science and science fiction, and the idea of alien contact would be great, or even just evidence of a past alien civilization even would be very good. So I am in favor of this. But what I'm interested in is it the right thing to do? And you talk about these telescopes, and the smaller ones, you're going to have these, say, 10 to 100 stations, and they're going to be taking photographs of things. But is photography really going to be showing you that much? Because a lot of the time what you see is images that are ambiguous. You see that now, and what you're trying to do, obviously, is to get an image that is less ambiguous. But is that really the best use of money?
Yeah, to get a better resolution image, all you need is a bigger aperture. So when people use, for example, cell phones, the images are always blurry for an object at a distance of a mile because the aperture of the camera is so small. But if you make a camera that is 100 times bigger, then you can get 100 times better angular resolution. So it's just about that, optics. But moreover, in a given station, in a given system, it will not be just one telescope. It will be multiple, like, for example, 2 or 3, so that you can get a parallax. You can see how the object moves in 3 dimensions on the sky. You can get a trajectory. You will get a better image of it because the telescopes are bigger than previously used. And moreover, we use detectors not just in optical light, reflected sunlight, but also in infrared lights and the radar systems in the radio. So, and we will have full control over the instruments that we are using. So we will know exactly what is happening. And I should emphasize, one of the most important aspects of our work would be that it's open data. Anyone will be able to access it. There will be no mystery about hidden data or whether high resolution data exists but not released, because it will not be classified. The only reason the data by the government is classified because it was taken by classified sensors, and the government doesn't release the data simply because it doesn't want to reveal the quality of the sensors being used to monitor our sky, so that adversaries will know what we use. And we don't have that problem. And by the way, I personally do not want to look at any classified data, because that would limit my freedom as a scientist. I don't want to be obligated not to think, because it will always be in the back of my head if I had witnessed the classified data. And if I don't see it, then we can just collect our own new data and examine it with a fresh perspective. I have nothing against other scientists looking at classified data, that we find, but I want to be free to look at new data. And the sky is not classified. Most of it is not classified, so we can just look up. The astronomers are using it, are looking at the sky all the time. The difference is that we will focus on nearby objects. I should say the Galileo project has 2 components. There is a second component that has to do with interstellar objects that came from outside the solar system and enter the solar system, like Oumuamua, for example, that look weird, objects that do not match what we are used to in terms of looking at comets or asteroids. And we just want to figure out their nature. Just like you walk on the beach and you see most of the time rocks, and every now and then you see a plastic bottle. So we want to look if there is any plastic bottle out there that enters the solar system, just to make sure that, that we understand what is coming in. And I should say, even if we find something like a hydrogen iceberg, like some people suggested for Oumuamua, to explain its weird properties, that's something we've never seen before, something that was not produced in the solar system. We know that. And, it should be very abundant, because Oumuamua was the first interstellar object that we discovered. So if we understand objects like Oumuamua to be hydrogen icebergs based on future evidence, that will be important for science, because it will imply that there are nurseries that make objects we haven't expected, that are very common, and we will learn something new. So my point is, with new evidence, you always learn. It's always beneficial to collect evidence. We are not using money that was otherwise intended for another purpose. We are getting donations. And so I would think that this project should get the blessings of all scientists, which it doesn't.
Well, no, it doesn't, I think, because of the association that it has with the UFOs. But like getting into that, I think, if you're going to go out on a scientific expedition, you're trying to gather some data to try to answer some questions, don't you have to have some kind of existing data set that kind of justifies what you're going to do? So like we've got all these existing observations that people have had, and we have a few videos and things like that. Do you think there's a sufficient data sets to justify what you're doing in terms of the telescope installations? And what would you say is the justification for this particular experiment that you are doing?
So interestingly, the justification for me was the fact that the ODNI, the UAP report to Congress, had a classified component. I didn't see any of that data, but it was presented to the White House. It was presented to many officials in past administrations. And when CIA directors Brennan and Woolsey, and when former President Barack Obama say that it's a serious matter, that they saw the classified component and it looks convincing, what I infer from that, and these are serious people, you see, that I trust, what I infer from that is that there is a mountain of data that we don't have access to, where the images are much crispier than we see. Okay, the public sees. Now, I haven't seen that data, but that's what I infer, because, if these people saw the same fuzzy images that the two of us saw, then forget about it. It's not convincing. But the way that they spoke about the subject, and that includes also Bill Nelson, the director of the NASA administrator, who expressed his wish that scientists would look into the data. And, I say these people saw the classified component, at least part of it, and they talk about it seriously. So that's sufficient. That's a sufficient threshold for me to say scientists should collect new data so that it's not classified, open data, and analyze it in a transparent way so that we get a clear understanding of this UAP phenomenon and move on after that. If it happens to be a natural phenomena, I have no quarrel with it. Whatever the data reveals, we will show to the public. And now, one thing to keep in mind is it's a mixed bag. It's probably a mixed bag, right? There were lots of reports in the past. Most of them probably have some mundane explanation, as you argued on many occasions. And that would be completely fine. The point is, we need to show that all of them, at least those that we can detect, have mundane explanations, and some of them may be exotic explanations, like rare phenomena in air or in the atmosphere. That would be fine with me. But even if there is one object that is of extraterrestrial origin, that would be major news, right? So what we want is to have a high enough quality of data on one that looks really unusual. And I don't care if 99.9% of all the objects we find appear to be made by humans or in the atmosphere and so forth. If we do find one that seems to be clearly not human-made and clearly not natural within the atmosphere of the Earth, that would be of a very interesting
event. Only need
so that would motivate me to continue the search, you see.
Yeah, so, but this kind of like data set, essentially, the UAP report that you're using as an impetus for the project, it's kind of vague, and it doesn't really give any specifics. There's no specific cases listed. There's no locations and no numbers or anything like that. So it's just giving you a kind of like a very broad thing. We think we see things in the air that we
I agree with you. I agree with you, and the reason for that is presumably that the more interesting data is classified. And you ask yourself, why would the intelligence agencies admit that they're not doing their job? Because if you just think about this report, they're saying, we are getting paid to do something and we are not doing it. They're telling Congress, we are not doing our job. That's an unusual admission, right? That there are objects in the sky that they cannot figure out.
Well, it's
And
the
to
limits
me,
of their abilities. I wouldn't say it's not doing their job. Is they admit there are things that their current capabilities
right,
can't
but
actually
that's their job,
resolve.
right? In terms of
Sure,
national security, their
but
job is to identify
you're
all the
also
yeah.
you're also saying that you think that they have crisp photographs. You think they
Well, so I
essentially
would
have what you are trying to get.
no, so I would say that they would not come out with an admission that they cannot figure out the nature of these objects unless the much better data that they have in their possession, which is not released to the public, indicated that they should make such a statement. Now, I don't know how good the quality of that data is because I haven't seen it, and I'm not interested in seeing it. I'm just saying, given that the most conservative organization that we have, which is the government, comes out with a statement like that, given that, you know, academia, which is a blue sky organization, right? It's supposed to be entertaining all possibilities, be open-minded. Given that the most conservative organization tells you there is something we don't understand, academia should respond and say, okay, we'll figure it out for you. Here we are to serve the nation, trying to figure out something that the government doesn't figure out. And to me, it's an interesting puzzle. You know, you might on weekends solve crossword puzzles, you know, and I would have nothing against that. So in much the same way, there is a puzzle here. There is a challenge that the government poses. And I, as a scientist, am intrigued by it and I want to resolve it. And I'm not using funds that were otherwise used for something else. I'm just saying, let's figure it out. It's fun. You know, science is fun and science is exciting. So why damp any investigation into the origin of a phenomenon the government admits it doesn't understand?
Yeah, and I like the idea of solving puzzles, and that's kind of what I do when I look at a UFO video. I am trying to just basically figure out what actually is going on.
Yeah.
So the technology that you're going to use is, you know, telescopes and radar and things like that. And for me, I obviously I would like to get photographs. So, real quick question: like, are you going to have? Will these telescopes just be taking photographs, or are they going to be recording video?
It's a stream of photographs. So it's a video, basically, video of the sky. Now the frame rate is to be decided. We want a high enough frame rate so that we can reconstruct the trajectory of an object. You know, so that we can tell if it's a bird, a drone, or a plane, or whatever. So we want to be able to tell what the object is doing in real time and get an image of it if possible, and then get its infrared signature, its radio signature, and possibly some sense of its spectrum if we have enough photons, if we have enough light collected.
So how is the installation know where to point the telescope? How is it going to lock on to an object?
Right. So we are still discussing it within the collaboration. You know, we just started the collaboration a few weeks ago, and we have a very lively discussion on the optimal instruments to be used and how to put them together. But the idea would be to have a telescope system that monitors as bigger as most of the sky, let's put it, above the site where it's located. And doing it continuously, and then the light is focused to a camera that takes a video of the sky, you know, with some frame rate, and it's a huge amount of data you have to understand, and we cannot store that. So there will be a very crucial component is, of course, the software that will be used to filter out. Most of the time you don't see anything interesting, but every now and then there will be an object moving, and that will be a target of interest. And of course, once we train the system, if it's an AI system or machine learning, whatever computer algorithm, there will be objects that keep repeating, like birds. You know, they behave in some special way. Their image has a special characteristic, and we'll just reject things that look like a bird. And we are not interested in drones or in airplanes either, you know, and so it will take time to train the system so that we reject those things, and we will look at everything else that is moving and doing things that are unusual and try to figure it out. And of course, as you said, the key is to cover a large enough chunk of the sky around the Earth so that we have an event rate that matches the rate that was reported by pilots. Now, I should say we might have a much larger event rate because we are using instruments that are far better than the eyes of pilots, that are far better than the instruments in the cockpit of a pilot, or in the Navy, or wherever these reports came from. And as a result, we'll see smaller objects at greater distances, and that would increase potentially the event rate. But we hope to get much better quality data, and therefore a much better assessment that will imply what these objects are.
So it sounds like from the filtering aspect of it, you wouldn't want to filter out, say, an aircraft just on the fact that it's a shiny metal cylinder in the sky, because that could be an alien spaceship of some sort. So you would be doing the filtering there, perhaps more on the motion of the object. Would you be looking for unusual motions?
No, I mean, if you get a high enough resolution of an airplane, it will be clear.
Okay, so you'd be doing just a visual elimination.
I mean, we pretty much know which airplanes are being used by humans, right? So
you can filter most of them out just by the ADS-B data, and you can just see what's up there already.
That's part of it. Yeah, we the software, as you are alluding to, is extremely important, because you don't want to throw the baby with the bathtub. I mean, if you are too selective, you will throw the baby with the bathtub water, so to speak.
So the filtering that you're going to be doing, then, are you saying it will be mostly a visual filter, or are you looking for specific movement patterns?
Well, it will be it will be the image, the movement, and of course, if we have multiple detectors, if we have different wavelengths that we are looking at, the signature in those different wavelengths will help us. And if we have multiple telescopes, of course, it helps a lot, because you can reconstruct the motion in 3 dimensions. You can have redundancy. That's very important, because if one instrument just happens to give you a false alarm because something, there is a malfunction in that instrument, then you will have others to check it. And so that's important, to have redundancy.
Yeah. So you talk about recreating the motion in 3 dimensions, which I think is very important, because if you're going to distinguish things based on the path and the motion, having a 3D recreation of that is very important. But can you actually do that with 2 telescopes in one location?
Oh yeah, because you can calculate the angular resolution you need to see a parallax, and it's relatively easy to put telescopes at a reasonable, even at a few meters separation, they can get a very significant parallax relative to their angular resolution. And the other thing I should mention is, if you assume the standard laws of physics apply, right, and you see an object moving faster than the speed of sound, then it should definitely make sound. It should make a sonic boom or something. And if it goes through water, it should make a splash, right? So the point is, I'm very curious to see that these effects are indeed noticed, because that would imply the object is real, and you could constrain the parameters of the object. So we will have also audio sensors trying to figure out, indeed, whether if we see an object moving faster than sound, it makes the noise that you expect from a sonic boom. And all of these things should be put together. According to what we know about physics, it makes no sense to imagine an object with some cross-sectional area moving through air and not making any sound.
Sure, yeah. Now, just digging a little bit into this whole issue of locating things with parallax, it seems like even if you've got a few 10-meter separation on 2 telescopes, and you've got something, say, 10 kilometers away, the amount of accuracy you would need would be quite significant. Now, the one big telescope you mentioned, the $500,000 one, could certainly do it, because it's super accurate and calibrated and fast moving. But with the smaller telescopes, would you be able to actually do that? Do they have sufficient resolution in their go-to mounts that they have to actually do that within whatever is required, like 1 arc second or whatever?
Yeah, it depends on the size of the telescope, as you say. And indeed, the 10 meters divided by 10 kilometers is roughly 2 arc seconds.
Right.
And so for that, you need a bigger aperture. You need something of the order of at least 10 centimeters. That gives you, if you take a wavelength of light that is half a micron, then something that is of the order of 10 centimeters or more can give you the angular resolution that you need.
obviously something that should be just simple engineering, I guess. Figuring out what the actual resolution of such a setup
and
would
we
be.
went through the numbers, and it works out. We have exceptional instrumentalists like Nick Loeb and Gaspar Bacos, who are leading our telescope design, and these are really the top people in the field of astronomy doing these things, and I was very happy to be able to recruit them to the team.
So let's talk a little bit about like some different approaches that might kind of mesh with this. Like suppose you're using full sky cameras that take a picture of the entire sky.
You mean like fisheye?
Yeah, essentially, yes. Or multiple cameras in different segments of the sky. So you're just getting full coverage of the sky, and you can see things in the sky. Could you use that with multiple from each station, so you could triangulate the position?
We are discussing that, except again, it's a question of cost and how many can you use, and but definitely that's something we actually have been discussing last week. So what you're saying makes a lot of sense, and so the issue is really how big of a telescope do we need, or if you have multiple telescopes, how to optimize the number versus size, and given the cost. And I should say that the distance to which you can resolve objects depends on the size of your aperture, right? So and now you have to assume whether the number of objects scales as distance cubed or as distance squared, because if the objects are just hovering above the Earth surface, then it's two-dimensional distribution. When you look towards the horizon, the number of objects that you see as a function of distance would scale like distance, the maximum distance squared. But if they are distributed at all elevations in 3 dimensions, then it will go like distance cubed. And and of course, then you have to decide, is it beneficial to have one big telescope, because then you can see much farther out, and you gain by the size of the aperture cubed, basically, in terms of the volume that you're covering, versus a situation where you have a lot of small telescopes, each of which is cheaper, but then each of them is able to resolve only a smaller volume. And, so we are going through these calculations.
Yeah. Well, most of the reports that we get are things that happen in the troposphere, essentially, like below, like, say, 30,000 feet.
Well, but that may be just because we were surveying those regions with, airplanes. We don't really know. And the other thing I should mention, there is another critical element, which is the distribution of objects as a function of size. You see, it may well be that the reports focused on some size because that's the size that was noticeable with either the pilot's eyes or instruments they were using. And I'm really curious to know what is the size distribution, because you can have many more objects that are smaller in size that you can only resolve with big telescopes. And so the number of UAP that you find will depend on the size distribution, which is completely unknown, and of course on the instruments that you are using. And if I had an infinite budget, if unlimited budget, I would use the biggest telescopes we can buy off the shelf, like 1 meter, let's say, or so, and then just get as many as possible, thousands of them or more, and basically cover the sky and just monitor
you can picture it, can't you?
Exactly.
Going everywhere, looking at these.
We just need enough funding. You can buy all these instruments off the shelf, and it's just a matter of putting them together for the purpose. And I should say, some astronomers said, oh, well, we have telescopes around the globe. We have satellites looking down. The point is, all of these instruments that are currently being used are not doing the job that we want them to do, because
one instrument that might be doing it is the space fence, which is essentially what the US uses for tracking space debris and space junk. And you talked about things that are very, very small. And the space fence, and there's an older version of that as well, use this multi-static radar, where essentially it's listening for reflections of radar pings of objects in
but
space.
they can't
It's got
resolve
multiple.
They cannot resolve it, probably, right? They cannot tell. They cannot make an image of the object.
They cannot take an image, but they can track it, and they can track
Right.
objects that are as small as, I think, 10 centimeters or basketball size. I think.
So, but the problem with that, it would be just like those fuzzy images. You know, we will know about an object moving in some. So you're right. We will be able to infer the trajectory, right? And
but I think the trajectory. The interesting thing about a lot of these things is, in fact, the trajectory, and it's often not so much what it looks like, which is often, you know, just sometimes a sphere or something like that. But if it has an interesting trajectory, like it is actually hovering in space, for example, or if it's moving and changing directions in a certain way, this is something that has been reported, and it would seem like, you know, an effort at gathering data on things that do that would be important. But it would also seem that if there were these things flying around in the atmosphere, then the technology like this space fence, the multi-static radar installation of the U.S. government would do it. But, you know, that's government. But you know,
that's
there's a possibility.
I don't want that.
I know you've been approached by people who've talked to you about Peter Davenport back in 2004. Proposed a UFO hunting method using multi-static radar, which uses FM radio transmitters and then a bunch of receiving stations to track objects in much the same way that the US space.
No, I mean, you're right that radars are very effective at doing that. And I will mention an anecdote that you may not know about. So after Oumuamua was discovered, I noticed that there is a table, you know, a website where they list meteors from the past that were detected by US government sensors. And they list the numbers about those, I mean, the velocity components of those meteors without giving error bars. And I asked my student, Amir Siraj, to look into that table and see if there is any object moving faster than you expect for meteors originating from the solar system. So if there is any object that could have originated from outside the solar system in the meteor data that was publicly available. And he found in 2015, there was a meteor that moved much faster than expected for an object bound to the solar system. And we wrote a paper about it and said, here is an example for a meteor that could have been interstellar in origin. And by the way, it was reported in 2015. So it predated Oumuamua. And we wrote a scientific paper, submitted it to the Astrophysical Journal letters, and it was refereed. And then the referee came back and said, we don't believe the government. There is no error bar on this measurement. Therefore, this paper should not be published. And so I said, okay, I know some people, you know, I chaired the board on physics and astronomy of the National Academies, and there was a member of the committee that works in Los Alamos and, you know, behind the fence, so to speak. And I asked him whether it's possible to get any upper limit on the error budget so that we can quote it and say, you know, the error is less than something, and therefore this object must be from outside the solar system. So after many months, he came back and provided the needed statement. So we put it in the scientific paper, and then the referee said, oh, that's not good enough. How do I know that I should trust this person that gave you that information? We want to see the data before we accept this paper for publication. So then the editor came up with a creative solution. He said, let me find a referee that has clearance to look at the actual data that was obtained by the government and tell us whether the data is reliable. And he couldn't find such a referee. So the paper was left in limbo. And it's really unfortunate because, you know, we are talking about a purely scientific motivation for getting the error budget on a measurement from 2015. And of course, the government has an issue because it will say something about the sensors that were used. That's why, you know, from this experience, I learned that it's best to collect your own data. I don't want to look at any data because there are layers and layers of bureaucracy that prevent us from having access to government-owned data.
I guess that's the idea there with the multi-static radar thing, is that you wouldn't use any government data. You would be able to set up a relatively cheap network of receiving stations that could cover the entire country and measure trajectories. And I think that would be a great
That would be great,
addition.
except it couldn't give us an image. So for the trajectories, you're exactly right.
But again, like I must say, like I think perhaps this the search for an image is, I feel, perhaps a little bit misplaced, the focus on just searching for an image, because really what you want to demonstrate is that there is something unusual. Now, sure, if you get an image of something that looks really weird, that would be great. But you've also got to demonstrate really that it's moving in an unusual way. It could be just a balloon or something like that. We can do both.
If we have an image and we see the trajectory in 3D with parallax, we can get both. And I should say, there is this saying, a picture is worth 1,000 words. In my case, I should tell you that a picture is worth 66,000 words, the number of words in my book, Extraterrestrial. Yes. I wouldn't need to write the book whatsoever if I had a nice photograph that I could show.
You list three things in the avenues of research for the Galileo project, and one of them was search for satellites. And you didn't mention that earlier. You just mentioned the first two. Are you still doing that, or is that Bernard?
That's obviously something of interest, but that would come third. So we will do in parallel the first two investigations, basically searching for identifying UAP, identifying the unidentified. That's the goal of the first component. And then trying to find the additional Oumuamua-like objects, either in upcoming data from Pan-STARRS or from the Vera Rubin Observatory in a couple of years, and then planning on a space mission that will send a spacecraft with a camera that will come close to these objects. If we are catching them early enough, we can intercept their trajectory, just like OSIRIS-REx came close to the asteroid Bennu and actually landed on it, and will bring back a sample in 2023. So in much the same way, you can easily tell the difference between a rock and an artificial object.
Okay, yeah. No, I'm like I say, I'm very much in favor of more data. I just, I want to focus on getting the right data, and obviously that's something that you all have talked about.
We agree on the fact that the existing data that was released to the public was not of high enough quality. What we don't know is whether other data is more convincing. We don't know that because we haven't seen it. What I'm saying is, let's try to get that data.
If for the public, but if it's classified, how are you going to? I'm not saying how are you going to get it, but wouldn't the government not want you to get this data if it's something that they would classify, or do you think it's classified for kind of boring reasons?
I don't believe the government has any agenda. I think the issue is really that the data was collected by sensors whose nature is classified, because we don't want adversaries, other nations, to know exactly what technologies we're using to monitor our sky. And because the sensors are classified, the data is also classified. That was my experience with the meteor, right? A meteor is a completely innocent event that has nothing to do with other nations. And nevertheless, the government had difficulties releasing the aero budget. And the reason is because it will say something about the sensors that were used. And the lesson I learned from that is the data may not be classified because of its nature, but more because of the instruments that were used to collect it. And I'm saying, let's get off-the-shelf instruments that we have full control over, and then the data will be open.
Yeah, that would be great. I would love it. So you do a lot of these interviews. I could tell you could pretty much interview yourself because you anticipate the questions.
Over the past 6 months since my book appeared, I had more than 1,000 interviews, probably 1,100 by now.
What do you think about the issue of science popularity and having to popularize science, and having to get your message out there as opposed to simply doing the science? I mean, do you feel like you have to do all this PR work, or is it something that you just want to do, or what?
Okay, so in this context, back in February, my publicist in the UK said, "Good job, Avi, you are selling the book quite well." And I said to him, "Look, I'm not trying to sell the book. I'm trying to convey a message which I think is quite important. And if the public would not care much about my message, I would still deliver it. And if the book didn't sell, I wouldn't care less about it. So it's really the message that I'm trying to convey. And my objective is simple. It's important for me that humanity as a whole, our civilization will be guided by the principles of science. That's really important. And therefore, as a practicing scientist, I've published altogether more than 800 scientific papers, and over the past decade, I published more than 500. So I'm really a practicing scientist. I have a lot of students and postdocs working with me. So I think it's important that a scientist, a practicing scientist, conveys that, and not someone that is popularizing science. So that's a very important distinction. There are a lot of people whose names who are quite popular and are discussing science done by others, okay? And that's a different job description. Here I'm talking about myself as a practicing scientist, trying to explain to the public why science is exciting and why it can address questions of interest to the public. So you see, the other issue that drives me is that the scientific community is not really always true to its mission definition. The mission of science is to learn about the world through evidence, through experiments. And often what you find in academia is people trying to promote their image so that they can get more honors and awards. And sometimes it collides with getting evidence because, if you believe in the multiverse, or if you believe in extra dimensions and things that cannot be tested, then you protect yourself against being wrong. And that's a very comfortable spot to be in. It's sort of like asking how many angels can sit on the tip of a pin. That cannot be tested experimentally, and maybe you can make very intelligent arguments about it so that you can demonstrate that you are smart and get honors and awards from people that do the same. So within your club, that, by the way, very often feels as if it's on a pedestal relative to the public, you can feel that you are smart, you are respected, and you don't care about what the public cares about. And that, I think, is a big concern about the current culture in academia, that academia could work on issues or topics that are not of relevance to society, that are not of interest to society, just because there is this built-in culture where the values are more about demonstrating that you are smart rather than describing nature as it is. Because if you were to ask what nature is about, you would risk making mistakes. It's a learning experience. Einstein made 3 mistakes in the last decade of his career because he was really curious about nature. And so my point is, in communicating with the public, is also to change the culture, which I think is not healthy right now, where people in academia are not necessarily driven. I mean, in science, I'm not talking about humanities, that's a separate matter. But in science, they are not driven by the ambition to collect as much evidence and discuss only topics that can be tested experimentally. There are whole cultures of people working on things, either conservative items where they just try to refine things we already know, or another community of people that do completely speculative things that cannot be tested, and that's a very safe place to be in. And both communities live in harmony. And I think it's unhealthy because we're supposed to be guided by evidence. We're supposed to be taking risks. And by speaking about it, I'm trying to promote a better reality. Of course, it's not pleasant for me to read things on social media that attack me personally, but it's not about me. You see, I'm trying to promote a better reality that would serve us well. And that includes what we discussed just before, trying to clear up the fog on a subject that the public cares about, sure, and scientists dismiss. And I think, once we figure out the nature of UAP, if it ends up being a mundane explanation, we move on. You will be free to discuss other topics that are more important, perhaps, like climate change and things. But we will know that this subject is over because we realize that these objects all have some explanation that is rather mundane. Let's move on. So I think rather than stay in this status quo where scientists dismiss subjects like that and the public cares a lot about them, but then there is this frozen situation of uncertainty, rather than do that, let's move on. Let's be forward looking and resolve these issues.
That's great. Yeah. And one last question I just want to kind of cover a little bit is kind of what would be the kind of the proof of concept of getting the project moving, especially in regards to getting images of things, because
Right.
a big issue that you have is the atmosphere. And for me, like the atmosphere is the limiting factor. If I take a picture of something horizontally that is 5 miles away, I just usually get a blurry mess, regardless of how big of a telescope I get.
Definitely.
So could you do something just as a proof of concept, like send a drone up like a few miles away at 20,000 feet or something? You have to get special permission,
that's an excellent point. And in fact, we were discussing this. First, we need to select the instruments based on the cost and effectiveness, just doing optimal system design. And once we select the instruments, we buy them off the shelf. Given the budget, I'm sure that we can buy at least a few systems, okay? And then, indeed, as you say, we need to test them, that they are performing. And one way to test them is to fly drones and see that they identify them, or look at birds and see that they can identify them, and see airplanes. Yeah, definitely, the testing is a crucial component. And I think in the coming months, once we converge on systems that we would like to use, in the coming months, we will be engaged in the testing phase, exactly along the lines that you said. And once we have a working system that is satisfactory, then we can produce copies of it as much as our budget allows, and then distribute them in various locations, collect the data, make it available to everyone. You will be able to look at the data, and the analysis that we will do will be transparent, so you can study it and decide if you agree with it. And it's all part of the standard scientific practice. That's what we try to normalize, the engagement that people have with this subject. Normalize, by normalize I mean make it open, transparent, and base it on better data. That's all. And that's the way science operates. We don't know what the dark matter is. We've been doing it for 4 decades. We haven't found the answer. I say that within the mainstream, we have situations that are much worse than, we invested the hundreds of millions, we didn't find anything. So why not do a little bit of, I'm talking about tens of millions, right, to clear up the fog on this subject.
Yeah, but you say clear up. I really think that's a very ambitious goal, because if you don't find something over, say, the next 10 years, and
we'll definitely find
1,000 stations.
We know that birds exist, right? We know that.
Yeah, well, sure, but you find something special. I mean, like, does that prove that nothing special exists?
If we don't find anything special, if we don't find anything unusual, that's an important conclusion. We just say, the UAP are all conventional things,
Or perhaps they all know where your telescopes are and they're hiding from your telescopes.
Well, okay. So as I said before, we will engage only in the laws of physics. We just use known physics, and we will not engage in any conspiracies here. I mean, that's the way science is done. We don't imagine things, ghosts or whatever. We don't say that they're trying. Of course, you can say that they try to avoid the telescopes we use, but we could put the telescopes in places that we do not disclose ahead of time, right? And we will just do our job.
Yeah, that sounds great. I look forward to what comes out of this. I think it's a very interesting project. And because I have been stymied so much by the lack of good photographs. And it's very frustrating when people tell you, I saw a UFO, and they give you their iPhone photograph and it's a little white dot.
I think we come from the same point of view, and the science that I do stems from my childhood. Basically, when I was a kid, I wouldn't listen to what adults tell me. I would like to figure it out myself, and that's the way kids operate. And they learn new things that the adults are not aware of this way. And it's unfortunate that when kids become adult, they lose most of the time their sense of curiosity, and they start to argue for things that they don't have good evidence for. They're trying to pretend that they know more than they actually know. And I could say that throughout my life, I was fortunate enough to maintain my innocence and childhood curiosity. And what you see in front of you is the same farm boy that was born 59 years ago. People that know me from my childhood would tell you that I haven't changed much.
Yeah, That's great. And I love that sense of adventurism within science is great, because I think it's something that we do need. We can't just be sticking with.
Why should science be boring? Science could be exciting. It shouldn't be boring.
Indeed.
And, even if we end up finding a boring answer, that's part of science. That when we don't know the answer to something, we should say we don't know. Adults often invent stories. When they don't know something, they invent. That's not necessary. You just say what you know. And when you collect evidence that doesn't show anything unusual, you just say it. I mean, that's fine.
Well, I'd like to thank you very much for this discussion. It's been very, very interesting, and I wish you well with your project. And I'm definitely going to be following it closely, and look forward to your first proof of concept photographs. That's going to be very interesting.
You, Mick. And if you do have that $1 million that you mentioned, we would appreciate.
I'll think about it. All right, Avi. Thank you very much.
Bye-bye.